Here I found another FRQ question about internal resistance. So let's look at this question. The circuit shown above, the current delivered by the 9-volt battery of internal resistance of 1 ohm is 3 amps. So they give you the EMF is 9 volts and the current that is leaving 3 amps. The power dissipated in R2 is 12 watts, and they want you to determine the voltmeter reading. So they plugged in voltmeter parallel to resistance 1 and 2, and they want you to determine the resistance 1 and 2. So the voltmeter is reading the terminal voltage, the voltage that dropped outside of the battery. So I have this is terminal voltage going to be measured by the voltmeter, and I have the battery, positive and the negative side, and the current is always going from positive to negative. So because the current is 3 amps, then that means right here I'm going to have some voltage dropped inside of the battery before it even comes out. And to calculate how much voltage is dropped inside, the current is the same, 3 amps, so you have the voltage, Ohm's law, I times R, and this is my lowercase r. So I have the voltage dropped is 3 volts. That means the voltage that is left is only 6 volts. Because if the battery produces 9 volts, then the total voltage that has to be dropped outside of the battery is 9 volts. But 3 of it gets dropped inside of the battery because of the internal resistance. So what's left outside of the battery is only 6 volts. Sometimes I explain to my students this way. So you have aliens like amps, because it's 3 amps. There's 3 amps leaving the battery. And when they're going, because the internal resistance of the voltmeter is high, the current is not going to go through the voltmeter. It will continue going through. So there's 3 aliens running, and some of these 3 aliens, they have to split, because right here there's 2 ways to go, this way or that way. So some of them will go through resistor R1, some of them will go through resistor R2, but by the time they get back home, they have to pay all the voltage they had when they left their house. So the voltage is like the money in their pocket. So it's like, if I have 9 volts, then I have to lose 9 volts when I go all around the circuit. So if I had 9 volts and the current is 3 amps, then when the current passes through internal resistance, it gives away I times R, which is 3 volts. Then whatever is left outside is only 6 volts. So it doesn't matter whether the aliens will run this way and get back home, they still have to pay 6 volts to get through this resistor. So they lose 3 volts here, and then they lose 6 volts here. So the whole circuit for those aliens, this complete circuit, they lose all 9 volts. But some of them will choose not to go through the first resistor. They will say, okay, wait a minute, I want to go through the second resistor. So the same, they will have to pay 6 volts over here, and then they get back home 3 volts over here on the internal resistance, and they're back home. So the total voltage that is dropped in the circuit is always 9 volts, because that's the voltage of the battery. So for the first part, for A, when they ask determine the reading on the voltmeter, we will say it is 6 volts, because 3 volts is dropped on the internal resistance. Then they tell you that the power dissipated on the resistor 2 is 12 watts. So if it is 12 watts, I know the power formula is equal to, power is equal to I times V, or I squared times R, or V squared over R. If I replace my I in V in the original formula, I will get the other 2 formulas. So I have to determine the resistance of 2, and all I know is voltage. The voltage between these 2 points is 6 volts. So I'm going to use this formula. So the power is equal to V squared over R. And I'm looking for R2, so that's R2, and the power on 2. So this is 12. Then I have V squared, which is 36, because it's 6 volt, my terminal voltage between those 2 points. So this is the same point because there's just wire in between, and this is the same point because there's just wire in between. So I have divided by R2. So from here I see that R2 is equal to 3 ohm. So my R2 is equal to 3 ohm. Then because the voltage between these 2 points, or these 2 points, is 6 volt, then I know that the current is flowing. So you have 3 amps going this way. And then the voltage between that point and this point is 6. So the voltage divided by resistance using Ohm's law, the voltage divided by resistance gives me the current. So the current that is going to go this way is equal to the voltage, which is 6, and the resistance is 3, is 2 amps. But as I mentioned earlier, you have 3 aliens running through this pipe. When they get to here and they have to split, 2 of them will go through resistor 2. Then 1 of them is going to choose to go through resistor 1. So when they ask you determine the resistors of resistor 1, you know the voltage is still 6 volts between the red dots. So you have the voltage is equal to IR again, but in this case it's R1. The voltage is 6, the current is 1, and we're looking for resistance 1. So the resistance 1 is equal to 6 ohm. So the resistance 1 is 6 ohm. That is all I wanted to show you in this question, AP Physics B 1976, question 3. And if there are any further future related to circuits or internal resistance videos that I record, I will try to post them in the description of this video, and the links will be provided in the description if there is anything else related to this topic. And thank you for watching, and I'll see you in the next video.